Lesson one was on constant velocity, and you are driving at 50 kilometers an hour and look at the radio for 5 seconds. How many meters have you traveled? Okay, so the givens that you have are velocity is 50 kilometers per hour, and the time is 5 seconds, and they want distance in meters. It makes sense to convert this 50 kilometers an hour to meters per second. You don't have to show your work as a conversion factor from the previous chapter, but 50 divided by 3.6 will be 13.88 or 13.89 meters per second. You pull up the single most used formula for this chapter is V equals D over T. Rearranging it for D, because that's what we're solving, is D is equal to velocity times time. And that velocity is 13.89 meters per second. And the time is 5 seconds. Okay, so then we just multiply those two numbers together. It's 13.8888888889 times 5, whatever the calculator said, 69.44. Question 2 was average velocity. And that was, you drive at 80 kilometers an hour for 2.5 hours, then 50 kilometers per hour for 125 kilometers. What is your average speed? Okay, so we have stage one, and we have velocity, distance, and times. And the velocity is 80 kilometers per hour. And the distance is, we don't know, the time is 2.5 hours. The second stage of this average velocity is we were traveling at 50 kilometers an hour for a distance of 125 kilometers. We're supposed to get the average. So the distance here is velocity times time, and that's 80 times 2.5, and that's going to be 200 kilometers. And in stage two, here we had to calculate the time, and time is distance over velocity, and that's 125 divided by 50, and that's going to be equal to, is that 2.5 hours as well? Yep. So it's a total of 5 hours and a total distance of 325. And how did I get those numbers? It's just adding the times and adding the distances, and you get the average is equal to distance over time. and that's going to be 325 divided by 50, which will be 65. 5. 325 divided by 5. Okay, now, because they're the exact same times, we could have just done an average of the two numbers. We could have averaged 80 plus 50 and divided by 2, and we would have got 65. But I just made this question up, fluky, that they were exactly the same amount of time. If it wasn't the same amount of time, you would not be able to average it that way. Okay, and the third one is relative velocity. So you let your little brother run ahead of you for 20 seconds, and he runs at 3 meters per second. You then start running after him at 5 meters per second. How far do you have to run to catch him? Okay, here it is. The rel. Okay, but we don't start there. I started way early here. Move that on over because there's a head start. You let your little brother run. So this head start, his speed is 3 meters per second, and his time is 20 seconds. So the distance of the head start is velocity times time. Just him running is 20 times 3 times 20, or 20 times 3, which is 60 meters. So that's the head start. Now you start running. So now once you start running, it's a relative velocity question. Once you start running, you're running in the same direction, so you have to subtract the speeds, and the catch-up speed is 2 meters per second. Okay, how far a head start was it? The relative, which is the d head start. Okay, that's a big clue. Some people don't get that. That the head start is how far ahead they are, and that's the relative distance that you travel. And that is just the 60 meters from before. So the time, that's all that you have to calculate because you have one formula, v d over t. That's the one formula for this chapter. You have two variables, you get the third. Time is distance over velocity, 60 over 2, which is 30 seconds. Okay? So it takes you 30 seconds to catch him. So you run at a speed of 5, and the time that you ran is 30 seconds. So the distance is velocity times time, and velocity is 5, and the time is 30 seconds. So this is 150 meters, a football field and a half to catch him. Now to check it, let's do brother, your little brother. His speed is 3. The time that he ran is the 20 seconds that he got a head start plus the 30 seconds that he ran while you started running. So that's 50 seconds. The distance that he ran, velocity times time, that's 3 times 50. He also runs 150 meters, and that's it. It better be. If you started at the same place and ended up at the same place, you travel the same. Okay, so that was our check. There was our answer, 150 meters. Number 4. A drill is spinning. Oops, sorry, the topic of number 4 is period and frequency. A drill is spinning at 400 RPM. What is its period and frequency? Okay, so period is the seconds per cycle. And the frequency is the cycles per second. Okay, those are definitions. We start off with 400 RPMs. So this is 400 revolutions per minute. So revolutions are like cycles. And so this is cycles per minute. Cycles per minute. We need to convert that to cycles per second, then we got the frequency. So got to get rid of the minutes and got to put seconds down below. And 1 minute is 60 seconds, so we've got to take this 400 and divide it by 60. So 400 divided by 60 is 6 2/3. And that'll be cycles per second. That'll be the unit because the minutes will cancel out. So that is this number, and that just happens to be the frequency. So the frequency is 6.667 hertz. And the period is going to be equal to 1 over the frequency. So this is going to be 1 over 6.667. So I reciprocate this answer, and I get the period is 0.15 seconds. What does that time represent? Those are the answers. But what is that time? Someone will say that's the period. Yeah, but what does it represent? Yeah, the time it takes for that drill to turn around once. The time it takes for it to turn around once. Okay? And number 5 is displacement versus time graphs. And we go a little bit further into here. We do position time graphs. And we also end up with a little bit of velocity time graphs. And one of the things we've learned in here is the slope of a dt graph is the velocity. Okay? A curving dt graph is accelerating. A flat dt graph is stopped. A constant speed on a dt graph looks like a line at an angle, kind of like that. And if it is curved, this is accelerating, and this is accelerating. This is a positive acceleration, and this is a negative acceleration. So these are some of the things that we did with dt graphs. Okay, so there's our quick, simple review. I did do a little bit of an advanced one on relative velocity where there was a head start, but just a simple advanced one if you want. Average velocity, I did the basic one here. Okay, the laps one with the race cars and stuff like that, that's the advanced one. Okay, or you averaged, you want to find out what it is. So I give you stuff for 1 and I give you the average, you have to find out what 2 is. Those are tough questions. And this one was just a tiny bit advanced because I did change units on you. So right now we're going to go over that worksheet I just handed out to you. And for those people that are on the internet, thank you very much for paying attention.